Hello. So now we're going to continue on to lesson 1.6, other types of equations. And at any point during this video, if you need to, please pause the video and then restart after you're kind of done figuring out or doing. You can even do that with the examples, before you see how they're worked out. See if you're able to try them on your own. But anyway, and again, do not hesitate to ask any questions. If there's anything that I say that's not, you don't think is correct or you don't understand, please um, contact me about it. So anyway, so other types of equations. Um, we're going to start with the polynomial equations. So a polynomial equation is the result of setting two polynomials equal to each other. Again, equation means equal. So the equation is in standard form if one side is 0 and the polynomial on the other side is in descending powers of the variable. Descending powers meaning the exponents. So going from largest to smallest. The degree of a polynomial equation is the same as the highest degree of any term in the equation. So the word poly means many. So this can be, I mean, even a quadratic equation is a polynomial equation like we saw in or defined in lesson 1.5. It is a second degree polynomial. When we go higher than quadratic, we usually use the we just talk about polynomial equations. Okay, so let's look at an example. Um, we are going to solve by factoring 2x cubed plus 3x squared equals 8x plus 12. So what we're going to do is we're going to move all the non-zero terms to one side. So I'm going to subtract 8x. Again, we're doing the opposite operation and subtracting 12. So we have what we do on the right side, we need to do on the left side. These cancel each other out, so we end up with a 0 on the right. And on the left, we end up with 2x cubed plus 3x squared minus 8x minus 12. Our second step is factoring. So what we're going to do now is we're going to factor. Let me do this. We're going to factor the equation that we just got. So if we look at the way we're going to factor this is we're going to group it. So we're going to go ahead and look at the greatest common factor of 2x cubed and 3x squared. Well, 2 and 3 don't have a common factor, so we're just going to look at the x's. We can factor out x squared from each of these. So when we factor out x squared from 2x cubed, we end up with 2x. X times x squared is x cubed. Plus, again, 3 is going to stay where it is. Well, it is 3x squared, and we factored out the 3, so it's just going to be a 3. Then we're going to go ahead and factor negative 8x minus 12. Well, both of them have a negative sign, so we're going to take the negative sign into front. The greatest common factor of 8 and 12 is going to be 4. 8 divided by 4 is 2, so we've got a, using the colors wrong. We're gonna open the parentheses. So 8 divided by 4 is 2. 4 times 2 is 8, so that's where we get this. And then we need the x here, so that negative 4 times 2x is negative 8x. So if we go back and distribute this, we get the same as what is over here. Then we're going to take the negative 12 and divide that by negative 4, so get the other factor other than the negative 4. That one is going to be 3. Now, if we look at these two, we have a 2x plus 3 and a 2x plus 3 here. So those factors are the same. So what we can do is we're going to continue the factoring. X squared minus 4 is going to be one of the factors, and the other one is going to be the 2x plus 3. And this is going to be equal. This should be set to equal 0 as well. So the 2x plus 3 goes here, and what's left is the other factor. Okay, now we're going to continue like we did by setting each of these factors to equal to 0 and solve. So we're going to do x squared minus 4 to equal 0 and 2x plus 3 to equal 0. So we are adding 4 to both sides. These cancel out. We get x squared equals 4. Well, that is a squared, so we can go ahead and take a square root, plus and minus. So we get x equals positive and negative 2. For the other one, we're subtracting 3 from both sides. We get 2x equals negative 3. This is a multiplication, 2 times x, so we divide by 2. And let me kind of try to make a little bit more room. So we get x equals negative 3 over 2. So our answer for this, the solution, notice that we've got our degree is 3. So we should have 3 different solutions, which we do. So our solution set is going to be negative 3 over 2 and plus minus 2. And we are writing it inside the braces, the squiggly lines, because it is a set. So all those 3 are our solution. Now, the one thing that you should always do at the end is check. So plug in all of the solutions that we got one at a time into the original equation. Not anything that you've done, like this one, not this one. We want it in the original equation, just in case you made a mistake somewhere along the way. Okay, so let's move on to the next one, which is radical equations. So a radical equation is an equation in which the variable occurs in a square root, cube root, or any higher root. And we solve radical equations with nth roots by raising both sides of the equation to the nth power. Okay, so the steps to solve a radical equation containing nth roots here. So again, if necessary, arrange terms so that one radical is isolated on one side of the equation. Second step, raise both sides of the equation to the nth power to eliminate the isolated nth root. 3, solve the resulting equation. If this equation still contains radicals, then you go ahead and repeat steps 1 and 2. And then, of course, 4 is always check the answers. Okay, so let's look on at this example and see what we're going to be doing. So step number 1, isolate the radical. So what we want to do is we want to move this plus 3 by subtracting 3 from both sides. So square root of x plus 3, the 3's cancel out, and we get x minus 3. That is how we isolate it. Now it's the radical is on one side and everything else is on the other side. Step number 2, we need to raise both sides to the nth power. So what does nth power mean? This is a square root. So all we want is to cancel that square root out. So the opposite of the square root is going to be squaring it. That will cancel the square root out. We have to raise both sides to the power of 2. So when we raise the square root to the power of 2, we get the square root goes away. So we get x plus 3 on the left, and on the right, we're going to have x minus 3 squared. Now, you have a couple of options what to do with the x minus 3 squared on the right side. What you can do is this is the same thing as x minus 3 times x minus 3, which means that you would FOIL first, outer, inner, and last, and then combine like terms. And when we do this, we get x squared minus 3x plus 9. So we get x squared minus 6x plus 9. So that would be on here, x squared minus 6x plus 9. Now, another one, if you are familiar with the formulas, you can use the a minus b squared, which gives you a squared minus ab plus b squared. So this gives the exact same answer as we got right here. But again, foiling is never wrong. Okay, now we need to move on and step 3, solve the resulting equation. So I'm going to go ahead and move over here. So solve. We've got x plus 3 equals x squared minus 6x plus 9. Now, it's up to you which side you want to move, or which side you want a 0. It doesn't, there's not like right or wrong. I'm going to go ahead and move the x plus 3 from the left side because it's less work. If I start moving the x squared and all that, there's 3 terms that I'm moving. So now my left side is 0. I know that we're normally used to so that the right side is 0. My right side is going to be x squared minus 7x plus 6. Now, looking at this, what I'm going to do now is I'm going to use, and there's different names for this one. There's AC method, there's the X, whatever you're used to. So what this means is that A times C and then B goes here. Well, I've got AX squared minus BX plus C. A is 1 and C is 6. So 1 times 6 is 6. B, actually it should be a plus B. B is negative 7. So what this means is that we need to find factors of 6 that add up to negative 7. Now, because this is a negative, that means that our factors are going to have to both be negative because negative times negative gives a positive. Um, so factors of 6, um, -1 times -6 is actually, you know what? Yeah, -1 times -6 is a 6. Well, -1 plus -6, this is a -7. So we know that our factors are going to be -1 and -6. Again, I'm just going quickly through this factoring. If if you need a review of it, Khan Academy would be the place to go to. So our factors are -1 and -6. So we can rewrite this as 0 equals x minus 6 times x minus 1. Now, our next step is to set these to equal 0 because we have a 0 here. X minus 6 equals 0 and x minus 1 equals 0. So again, we're adding the 6, so we get x equals 6 and we get x equals 1. So these are our solutions as of right now. Now, what we want to do is we want to go ahead and check. I'm going to go ahead and check on the additional paper, check at the end. So we're going to, when we're checking, we're taking the original equation and we're going to check and make sure that everything works. So I'm going to go ahead. Why do I not have an extra paper here? That is interesting. You know what? Then what I'm going to do is I'm going to go ahead and, you know what? I think I can fit the check here. I should have done this a little bit differently. There's, okay. All right, check. So x equals 6 and x equals 1. We're going to take the original and we're going to first, actually, we're just going to first do the x equals 6 here. 6 plus 3 inside the square root plus 3 equals 6. 6 plus 3 is 9. Square root of 9 plus 3 equals 6. 3 plus 3 equals 6. 6 equals 6. So this is correct. Nothing wrong. I mean, that's fine. Now we're going to take x equals 1 and do the same thing. And I usually like to put it underneath because it's easier to see, just because I didn't plan properly here. So it's kind of, I'm running out of room. So I'm plugging in 1 where the x is. So 1 plus 3 is 4. 4 plus 3, and this should equal 1. Square root of 4 is 2 plus 3 equals 1. Well, we can see that this is not correct. This is false. So this here is true. So the x equals 1 is what's called extraneous solution. So it is not a solution because it gives a false. So our correct solution is just the x equals 6. Okay. Next, we're going to look at equations with rational exponents. So we know that rational exponents represent radicals. So for example, a to the power of m over n, What this means is that the n on the denominator here is the root. So this is the nth root to the power of m. We could also write this a to the power of m and then take the nth root after. Either way is correct. So a radical equation with rational exponents can be solved by isolating the expression with the rational exponent and raising both sides of the equation to a power that is the reciprocal of the rational exponent. Now, word reciprocal. Reciprocal means that we flip it over. So for example, if we have 2 over 3, reciprocal would be 3 over 2. So we're just flipping it over. So that's what we're doing. Okay, so let's go ahead and look at our example. 5x to the power of 3 over 2 minus 25 equals 0. So again, what we need to start with is adding the 25 so that on both sides so that we are moving it to the other side. We're trying to isolate x. So y 5x to the power of 3 over 2 equals 25. We have the 5 here, multiplication, so we are dividing by 5. So we end up with x to the power of 3 over 2. 25 divided by 5 is 5. Okay, now we have that x to the power of 3 over 2. What we're going to do is we're going to go ahead and flip it over and set this to power 2 over 3, so 2/3. What this does, if you think about the 3 over 2, so I'm just writing the exponents here. 2 and 2 become a 1, 3 and 3 become a 1. So this ends up being 1. So they cancel each other out. If you want to do 3 times 2 is 6, 2 times 3 is 6, this is a 1. So either way, these cancel each other out, and so we end up with x equals 5 and 2/3. Now, we don't want to leave our solution with the rational exponent. So either we want to write it as cube root of 5 squared. Well, 5 squared is 25, so we can actually do the cube root of 25. Now, cube root of 25 is not a whole number, so we're going to go ahead and leave it as that. Now, of course, you should go back, as always, and check your answer that it is correct. But this one is if we go backwards and check it, we'll get a correct answer. Okay, equations that are in quadratic in form. So an equation that is quadratic in form is one that can be expressed as a quadratic equation using an appropriate substitution. So what we're going to do here is we have an example to solve right here. You can see that we've got x to the power 4 and 5x squared plus 6 equals 0. We don't have the term with the x and we don't have the term with the x cubed. So what we can do here is we know that x to the power of 4 is the same thing as x to the power of 2 to the power of 2, right? So what we can do is we can let u equal x squared. So this means that u squared is x squared squared, which is x to the power 4, right? So we're going to go ahead and substitute the u's in there. So instead of x to the power 4, we're going to use the u squared, which is the same thing. So u squared plus 5, x squared is u, so 5u plus 6 equals 0. And now we can go ahead and factor this again. So we get u plus 2 times u plus 3. And how did I get those factors? If I go here and do the AC method, so A times C, so this is 1 A u squared plus BU plus C. So 1 times 6 is 6, and then our B is 5. So both are positive, so our factors have to be positive. Factors of 6 that add up to 5. Well, we already learned that if we do the factors 1 plus 6, that's going to be a 7. 6 is divisible by 2, so factors 2 and 3, 2 times 3 is 6, so we can add those and we get the 5. So we know that our factors are 2 and 3, which are right here. Okay, and now we're going to go ahead and solve. So u plus 2 equals 0, and u plus 3 equals 0. So we get u equals negative 2 and u equals negative 3 because we are subtracting those numbers. Now, the one thing that we do need to remember is that we are solving for x and not u. So we have to go and plug the u or the x squared back in. So we get, when we do that, we get x squared equals negative 2, and x squared equals negative 3. You know what? This is going to create a little bit of a oh yeah, because there's a mistake here. Oopsie. Okay, so let's solve these and I'll show you where the mistake is. Not in the calculations, there's actually a mistake in the original, this one. So we're going to go ahead and just take the square roots like we do. We need to remember the plus minus, plus minus. So we get x equals positive and negative square root of 2. And remember that negative inside the square root was I. Same thing here. We get x equals positive and negative square root of 3, and it is an I. So I forgot when I started this problem. So our solutions are going to be these two. When I started this problem, they're actually, I'm thinking that this should have been, because the way the PowerPoint is, this should have been instead, that's part of that, x to the power 4 minus 5x squared plus 6 equals 0, which gives us u squared minus 5u plus 6 equals 0. Now this is going to be u minus 2, u minus 3 equals 0 because of this negative right here. And this would give us u equals 2 and u equals, I'm taking shortcuts here because I'm just showing that this is, so we would get x squared equals 2 and x squared equals 3. So take a square root plus minus square root plus minus, so x equals positive and negative square root of 2. X equals positive and negative square root of 3. On your exam, there's not going to be things like this. It's going to be clearly, but this is what, like, the PowerPoint shows these answers. But if you go with this original, these are the correct answers for the original equation. So that's what I'm talking about right here. Okay. Next, we're going to go ahead into equations involving absolute value. So absolute value of x describes the distance of x from 0 on a number line. To solve an absolute value equation, we rewrite the absolute value equation without absolute value bars. So remember absolute values. So for example, if we have -2, absolute value of -2, this is 2. So the bars are the lines that are around. If we have an absolute value of 2, it's also 2 because it is the distance. So both -2 and 2 are 2 units away from 0 on a number line if we put them on a number line. So we're going to go ahead and rewrite an absolute value equation without absolute value bars. So if C is a positive real number and U represents an algebraic expression, then absolute value of U equals C is equivalent to U equals C or U equals -C. Okay, let's try an example here. We are to solve absolute value of 2x minus 1 equals 5. So what we're going to first do is we're going to write it like this without the absolute value bars. So we're going to have 2x minus 1 equals 5. Oops, I keep touching it. Or 2x minus 1 equals -5. So we're going to go ahead and solve for x just like we've done, adding 1 to both sides. 2x equals 6, dividing by 2, and we get 3. X equals 3. This one here, we're adding the 1 also. We get 2x equals -4, divide by 2, and we get x equals -2. So our solution set is -2 and 3 for this one. And now, again, you should, as always, check that this is correct. So plugging one at a time inside the original one. Okay, we've got one more example. Oh, now it's giving me more paper, not before. Anyways, so we've got an application here. We have the formula h equals -2.3 square root of I plus 67.6 models weekly television viewing time H in hours by annual income I in thousands of dollars. What annual income corresponds to 33.1 hours per week watching TV? So this 33.1 is the H. So we're going to go ahead and plug it in. 33.1 equals -2.3 square root of I plus 67.6. I'm going to go ahead and isolate the I. So I'm subtracting 67.6. Again, what I do on one side, I do on the other side. So I get -34.5 equals -2.3 square root of I. I divide by -2.3 both sides. And again, use a calculator. Even how, I mean, these are a little bit harder, but even how small it seems, make sure that you're using a calculator so you're making sure that it is, you're not making like the silly mistakes of miscalculating something. And write everything down on a scratch paper. So -34.5 divided by 2.3 is 15. And we have the square root of I. Well, we need to get rid of that, so we want to square both sides. 15 squared is 225, and that is our I. So what does this mean? An annual income of 225, and now notice it says in thousands of dollars. So we need to add 3 zeros, corresponds to 33.1 hours per week watching TV. Okay, that's it for lesson 1.5. Again, please don't hesitate if you've got any questions. Bye.